Good morning, class. Welcome to potential spring, day 726. We'd rather be in person, of course, but we will make do. We're on page 656 in your book. Gonna finish out 9.4 here. Again, that's the last one we're gonna cover from Unit 9. Tomorrow, Wednesday, we will have a little review assignment. Thursday, we will take the test from Unit 4 over 1 through 4 from Unit 9. I'm not sure if I said Unit 4 there or not, but Unit 9, sections 1 through 4, test on Thursday. Again, if we end up changing the schedule from there, I will post it on the lesson plan page. And if we come back over a long weekend, we will make do and adjust accordingly. So keep an eye on the lesson plan module as we get more information. But the first question we're going to talk about is geometric mean. Are the terms between any two non-consecutive terms of a geometric sequence, and it gives us an equation, probably the easiest one you're going to have. So if you ever want a geometric mean, you multiply them and take the square root. So question 4 says find the geometric mean of a half and 1/32. You multiply those out and take the square root, and it is that simple. To check it out, same thing. 16 and 25. You multiply them and take the square root. If you need a decimal equivalent, that's fine. Those two turned out pretty nice. So just like talking about arithmetic series, now we're going to talk about geometric series. This is the same thing as we have been doing, except it added them all together. That's the difference between a series and a sum, or a series and a sequence. So the equation here, middle of the page, again, something good to get into your notes. Obviously, R is common ratio. Does make note that the common ratio cannot be 1. A1 is the first term, and so on. So it says find the indicated sum for the geometric sequence. So doing the first 7 gives us the first 4 there. First step is to find the common ratio. We'll just follow this one right here. So the common ratio, -6 divided by 3, or 12 divided by -6, -24 divided by 12. The common ratio is -2. All right, so we're going to plug it into our equation then. We're looking for the first 7. First term is 3. 1 minus the common ratio. And I'm looking for 7 of them. And then 1 minus -2. Remember, 2 negatives in a row make a plus. So this one should be simplified a bit. -2 to the 7th is -128. So it's minus a negative, so I'm going to change it to a plus. And then the bottom is, of course, 3. 3's actually can just cancel there. You're left with 129. Try typing this in and see if you can save some time in the future for doing those instead of having to simplify. Some are easy and things simplify nicely. Same thing with the next one. Gives us to a summation notation. Actually gives us the common ratio. This is what I'm multiplying by. So the first step is done. Ratio is a third. This one does not give me the first term, so I got to figure it out. If I plug in 1 here, I have to get the first term. 1 minus 1 is, of course, 0. Anything to the 0 power is 1, so 1 is my first term. So I have the common ratio, I have the first term. Now I can just plug it into my equation. So I'm looking for the 7th term. Nope, not 7th. 5th term. Again, up on top of the summation notation, it tells me how many terms I'm doing. 5th term, sorry, I thought it was 7th, just like the last one. Equation, 1 minus the common ratio to the n power, so to the 5th. all over 1 minus 1/3. Again, make sure you can plug that in and get an answer. It looks like you get about 1.49. Just double check that you're able to simplify that. Obviously the times 1 I'm not worried about, but it's a little tricky with the negative and some fractions there. So just make sure you're following order of operations. Make sure you can get that answer. It does give you 2 more examples. I'd like you to try those on your own. I'm just going to show you what I got. Guessing that first one, you would give a decimal equivalent. 63 divided by 16 should be about 3.9375. That is exact, so about 3.94. This one does come out nicely, so if you'd like another example using those formulas, please try those out. Okay, the back page. Talking about Wimbledon, or in March, the big basketball tournament, March Madness. It says you begin with 128 players. Players compete until there's one winner. How many matches are there? Okay, how many matches are there if you start with 128 teams or players in a tournament? So if we write the sequence out, now if you have 128 and they play each other, that is a first term. There are 64 matches to start. That is the key. It doesn't tell me how many I'm starting with. It's 64 because they're all playing each other. So it's a half of 128. And then each time you're going to lose half the teams. Okay, so there's my equation. Pretty simple. Okay, how long until there is one left? Okay, so I'm going to solve this, hopefully, for one team left. So I'm going to divide by 64 first. And then I'm just going to rewrite 64 using the power of 2, because that's just going to make solving these a lot easier, because if the bases are the same, the exponents are equal. So all I have to do is say 6 equals n minus 1. Again, 2 to the 6th power is how I got that, 64. So what minus 1 is 6, so that of course would be 7. Okay, so that's how many rounds will be required. And you can check your NCAA bracket to confirm that. 7 rounds required, so I need to figure that out. And I'm going to add them all together. You could do it manually. 64 plus 32 plus the Sweet 16 games, and then the Elite 8, Final 4, so on. Okay, but we're going to use our equation. A1, I'm starting with 64. It is 1 minus a common ratio. 7 rounds, that's what I needed this number for. Over 1 minus a half. Again, double check that you can type that in with no issues. 1/2 to the 7th has to come before you subtract. Follow order of operations. And you should end up with 127. So 127 games or matches at Wimbledon, or your, again, NCAA bracket, in order to complete all the games. Makes sense that it is an odd number. They are all even except for, last time when there is one team standing. So here we go. Your assignment. It is page 659 and 660. And I'd like you to do numbers 28 to 40. Again, that should be from examples 4, 5, and 6. So there you go, 26 through 40, and due tomorrow. Have a good rest of your day.